going to the multi-load configurator. I'll just go over the sections of this tool to start with. So over here at this side you have all your system rails. So in this case you could have something, you could have a 48 volt system rail, you could have a 12 volt system rail, a 5 volt system rail. So it just gives you whatever options are available in your system for resources for voltages coming in. You can have just a single voltage, or you could have multiple different rails. The power calculation is, if you haven't defined any outputs, this will be whatever the power is of your input specification. But as you start to add outputs over here, it will remove power from these rails to show you what the unused rail power is. So it's kind of keeps track of your power budget off of your rails. And it does that with an assumed minimum efficiency, because at this point you do not know what the actual efficiency of the system is going to be. So we just assume 85%. So all my power calculations will remove power from the rail based on an 85% efficiency. You can change that number up and down to your own desire. Okay, so moving over, this is the next big section here where it allows you to define up to 10 outputs for your system. So what you would do is go in here and you define, output 1, what your voltage and current is. If there's any special considerations for that output, whether it needs to be an LDO or if it's a switcher and it needs to be synchronized to a synchronization frequency, you would highlight these with a yes in these boxes. Obviously, if it's an LDO, synchronization is not going to be available. Sequencing, you can define your up sequencing for all your supplies. Your down sequencing is an inverse of that up sequencing, is what we support right now. Optimization is something we'll get into a little more once we actually show some outputs here, that we can show how optimization works. Open design templates. We have, I think, about 234 design templates available, so you can see a lot of FPGAs in here from all the major brands like Altera, Lattice, Xilinx, and we've broken it down into the different series and part numbers for those different ones. So any one of these templates can be loaded and it will bring in the base requirements for that processor, and then you can FPGA, and then you can manipulate that template to whatever your actual needs are. It just gives you a nice starting point. I have an example one here that I'll bring up here in a minute, that you can load. You can also save templates. You can save them as a new name, or you could save them as the name that exists in the system and replace the data with your new configuration. One nice feature we also support is import capability. If you're using a Xilinx FPGA, Xilinx has some tools for calculating the power requirements for your FPGA. They have some Excel tools that create a CSV type file that's .pwr. That file can be imported directly into this tool, and what it will bring in is all the rail requirements, all your system rail requirements, and it'll default your system rail supply input, but you can always change that and say if you're running from a 5 volt or 12 volt, you can change that on the fly there. The solution filters, which when we actually run one here, we'll get into that a little bit more here. So it's limiting topology results to 5, sorting by price, showing all solution types, AECQ qualified automotive type parts I'm not actually showing in results. Schematic filter is off. If you only wanted to see parts that you could generate a schematic from, then you would have to enable this. That way all your results will only be schematic enabled parts. By default, we do indicate this another way. We have, when the checkboxes come up on the parts, they'll have a blue background to the checkbox. Those are parts that can go directly to schematic. We're supporting almost 80 parts, I believe, now to schematic, the most popular ones, but we're continuing to add these all the time. So if the part's not on there now, hopefully it will be soon. And then synchronization. You can define synchronization at a rail level, which means it only applies to that rail, or you could apply it to the whole overall solution that you need synchronization on all rails with the exception of LDOs.